Welcome to this intro to organic synthesis video. So in this video, I am going to focus on how you can prepare yourselves for your organic chemistry exam. So there will be two of them, organic synthesis as well as your unified paper. And in the future, I'll also post some other videos on some of the more challenging topics. So there will be more on organic synthesis as well as like redox and your buffers and half cells, so that's just to name a few. Now, if as I'm posting more, there's a certain topic you want me to go through, just leave a comment. I'm more than happy to make a video on it. So with this video, like I said, I'm going to focus on how to prepare you. So one of the most challenging things with organic chemistry is not the reactions themselves. They're not hard. And if you really think about one reaction on its own, you're probably quite confident with it. What is hard is recalling so many reactions. So I've created this mind map that kind of consolidates all the reactions. So you have year 1 and year 2 reactions on this mind map. They're not all here. So benzene, phenol, I left them out just to keep this mind map nice and simplified. I will do a video on the reactions of benzenes and phenols though as well, so look out for that. But this mind map consolidates most of the others. And if you can work to memorize this mind map, then when you get to your exam, you sit down, the exam starts, you take a blank piece of paper, just write out this mind map as quick as you can. You don't want to spend too much time writing a note, but get as much as the information written down straight away. That way, it's on paper and you have a tool that can help you when you get to a really challenging synthesis question. Because all you have to do is think about, well, what functional group is on the molecule, find the functional group on this mind map, and you'll know the reaction, you'll know the conditions, and you don't have to sit there staring at the question, trying to recall the information. Okay, so it's a really, really handy tool. You can't bring it in with you to the exam, but once you get there, you can write it out so that you have it available to use. So memorizing this, there is a lot on here, and I would never expect anyone to have it memorized on first glance. So it will take time, just break it down. And the more you repeat writing out this mind map, the more you see it, the more you'll start to have it memorized. Okay, so it is laid out to help the brain recall it. So if you just keep it in nice columns, okay, the first time you write it out, let's call that your master copy, you might want to use a ruler and make it nice and pretty. But the following times, you probably don't want to spend the time doing that. But you can lay it out in a similar way. So alkene, then ester, then your carboxylate, which is your salt, alkane, haloalkane, alcohol, aldehyde, carboxylic acid, acid anhydride, and so on and so forth. So if you start with just memorizing these homologous series, so all these functional groups and where they go, you can then work on building on how they're all connected. Okay. So the first time you're going to start with this memorization task is when you write out your master copy. The next time is when you're actually doing a synthesis question. So you're going to practice some questions, you're going to put your master copy away out of sight, and you're just going to get a blank piece of paper and you're going to write as much of the mind map as you can by memory. Okay, when you get to the end, you can't remember anymore. That's when you're going to take out your master copy and fill in any of those blanks. Okay, so anything you forgot, fill it in. And as you're filling in some blanks, just try and take maybe 2 of the reactions and see if you can put them to memory. Okay, so build on that memory. Focus on 1 or 2 more and just see if you can set that into your mind. Okay. Then once you have it written out, you're going to use it for your synthesis question. Okay, and I will show you very quickly on how I use it, and by all means you don't have to use it the same way, but it does work. Okay, and then the next time you come back to revising and you're doing another synthesis question, you're going to do the same thing. Master copy away, out of sight, blank piece of paper, and again, write out as much as you can by memory. Ideally, you'll eventually be able to do it without looking at the master copy. Okay? And then when you do have it memorized, keep trying to write it out by memory. Don't just say, oh, job done, I have it memorized, I don't need to do this anymore. Because if you stop using the information, the pathways that help you recall that information start to weaken. Okay, so you want to keep on reinforcing these pathways in your brain. You don't want to lose those connections, okay? So just every time you're doing a synthesis question, your first thing, or even an organic chemistry paper, you're going to do a practice paper, your first step, just write out this mind map, okay? So how to use it? I do have a very simple question, one that you probably straight away are like, I don't need the mind map for it, I know this, but I just want to show you the connection between the two. In a future video, I'll show a harder question, in which case the mind map might come or be a little bit more obvious of why it's useful. But let's take a look at this question. Okay, so we have a chemist reacts the following compound with hydrogen bromide, HBr. What is the name of the major product? So if you're going to be using this mind map, you have to be able to identify the functional group. Okay, so I am making the assumption that you are comfortable with your functional groups. Okay, so we have our double bond, carbon-carbon double bond. There is no other functional group there, and that is our alkene. Okay, so we have our mind map. We're looking at positioning where we're finding where our alkene is. It's right there. And we have 3 possible reactions. Okay, so on here we have, obviously this is a reactant. We have our other reactant on the top of the arrow, pointing to our product, our alkane. The bottom of the arrow are the conditions that are needed. So this particular reaction, it's an alkene with hydrogen, and we need a nickel catalyst in 150 degrees Celsius. Okay. We also have this reaction here where alkene reacts with a hydrogen halide or a halogen. Okay, and when an alkene reacts with either one of those, we end up making a haloalkane. Now, one thing to note, I did highlight this in blue. That means you do need to know the mechanism for that reaction. Okay, and actually there's a few of them highlighted in blue where you need to know the mechanism. If we take a pause from our practice question quickly, this one in particular, going from an alkane to the haloalkane, I've highlighted in blue, but this is one of the mechanisms where you don't need to know how to use curly arrows. Okay, all the other ones you do need to use your curly arrows to show the movement of electrons. But this one in particular, you just need to know that initiation, propagation, and termination. Okay, and you have to know the reactions that take place in all 3 of those steps. Okay, so don't forget initiation, propagation, termination for that reaction. Another side note, you'll notice I have a reaction highlighted in pink there, and that's because an ester, when it reacts with sodium hydroxide, you end up getting 2 products. So you will produce an alcohol, but you'll also produce a carboxylate. So I highlighted in pink just because it was quite difficult to show on this mind map that one reaction forms both products. Okay, there is another one that you end up getting 2 products, and that's your acid anhydride reacting with an alcohol. You'll make that carboxylic acid as well as an ester. I did not highlight that in pink because it was a little bit easier to split that arrow to show the 2 products. Okay, right, so back to our question. We went through those 2. An alkene could also react with steam and your phosphoric acid in 300 degrees Celsius to make an alcohol. Okay, now of those 3, the one we need to focus on is that one there, because the question says we're reacting with hydrogen bromide. Okay, so we have our mind map in front of us, and we can see that actually we don't need to worry about any conditions for this one. Okay, so let's take a look at this reaction then. It is one you need to know the mechanism, so I am going to go through the whole mechanism as well, just in case you're a bit wobbly with mechanisms. Okay, so I'm going to rewrite this molecule, and I'm going to write it H3C to C. Now I wrote H3C instead of the CH3 because often, whoops, if we do CH3 and we show that bond, we get a little bit sloppy and we write it like that. Now that is showing that it's a carbon-hydrogen bond. Okay, and that actually is very wrong. If you did that in an exam, you will lose marks, and potentially all the marks, depending on where they're allocated, okay, and whether or not the error can be carried through or not. You don't lose carry through. So in a calculation, if you carry through an error, they don't penalize you more than once. But with something like that, when you're drawing molecules, if you're repeatedly drawing it wrong, you won't get your marks. So just be careful. So that's why I'm writing it H3C, so that I'm not making that mistake of showing the wrong bond. Okay. All right, so that's our molecule, and it is going to react with HBr. Now, when we're initially writing HBr, if you're using pencil, you don't really have to worry about if you're writing it this way or that way. Although, once we go into adding our partial charges, you will end up flipping it to the correct way because it's easier to draw your curly arrows. So we're going to do it that way. Now our partial charges, we do have a partial charge because there's a difference in electronegativity. Your bromine is more electronegative, so it's going to be partial negative, hydrogen partial positive. Okay, so that's because the electrons are being held closer to that bromine. And then our double bond is going to have a high electron density, so it's going to be slightly more negative compared to the rest. Okay, so it's just a higher electron density, which means this is going to be attracted to that. So we have an electrophile being attracted to the dense electron cloud there. So the electrons are going to end up moving towards that area of positivity. So if we show that, that bond is leaving, so we're breaking the carbon-carbon bond, and the pair of electrons is moving towards the hydrogen. So we're breaking one of the bonds between those two carbons, and we will be forming a bond between a carbon and that hydrogen. So it is a pair of electrons that's moving. Now this pair of electrons is also going to be moving, and it's going to be going to that bromide. Okay. So that's our first part of our mechanism. Now I did say we're going to be forming a bond between a carbon and this hydrogen. Now that bond can be this carbon or that one. So it can be either carbon. So we are going to have two intermediates that form. Okay, so I'm going to start with the first intermediate where the hydrogen forms the bond with that carbon. There's our hydrogen. The rest of the molecule is the same, apart from this is now a single bond. Okay. And we'll see that this carbon only has 3 bonds. Okay, and it's lost an electron, so it's going to have a positive charge, and that's our carbocation. Now the other one, the other intermediate, will be in the hydrogen being added to this carbon. So let's write that out. Still a single bond there. I lost my track. All right. So now we have this carbon, 3 bonds, lost an electron, so that's where our positive is. Okay, so we have 2 intermediates, and both of them can form, but one will form more often than the other. Okay, and that is related to the stability of this carbocation. So this top one, this first intermediate, our carbocation has 2 carbons bound to it, so this is a secondary carbocation. This one down here, that has 3 carbocations, so this is actually a tertiary carbocation. Oops. Okay. Now between the 2, your tertiary carbocation is going to be more stable. So when these intermediates form, we're going to have a higher probability or more of this carbocation forming, which means that from this molecule, our Br minus, we think of the collision theory, if we have more of this carbocation, the probability of these 2 species colliding is far greater. Okay, so if these species are colliding more often, then that collision will result in our major product. And our question, key part of our question, is asking us the name of the major product. So we do have to focus on the collision of these 2 species, so this intermediate and our bromide. Okay, and for this question in particular, we're not looking at the reaction of this top intermediate. Okay, so I'm going to erase them and we're going to look, or sorry, I'm going to erase all of this and we're going to look at that final mechanism of the reaction with the bromide and our tertiary carbocation. Okay, so if we rewrite this, so that was our carbocation. Okay, now we have our bromide. Now, the last time I wrote out the bromide, I did not show the lone pair of electrons, but they are there, and I am going to show them in this part because it is important to have them for the mechanism, because remember the mechanism is showing us, or the curly arrow, sorry, are showing us the movement of electrons. So I am going to have that arrow very, very specifically and clearly start at that pair of electrons and point to the carbon. Okay, it's quite important that you are not ambiguous with where your arrow is starting. So if we had been a bit lazy and just started our arrow up there, the examiner could look at that and think, oh, I'm not quite sure if they mean it's these electrons that are moving. And if they have any doubt, if they're not sure of what you're trying to show, you won't get the marks. So don't lose those marks. They're not worth losing. Okay, so just have it very clearly starting at the electrons and very clearly pointing to where you want to go. So same thing with the start of the arrow. Don't be sloppy with the arrowhead either. Okay, make it very, very clear where you're pointing the arrow to. So it's going to that carbon. So our major product, there is Br. The rest is staying the same. Okay, and the question wants us to name it. So thinking back to our nomenclature, we're looking at the longest carbon chain, so 1, 2, 3, 4. So we're going to have a butane. Okay. And then looking at what is branching off of that major chain. So we have a methyl group and we have our bromo group. Now naming these, you always want to make sure that what is coming off your major chain is named on the lowest possible carbon. So we could name it 1, 2, 3, 4, where these would be coming off the third carbon, or 1, 2, 3, 4, where both of these are coming off the second carbon, and 2 is smaller than 3, so we're going to name it 1, 2, 3, 4. And then bromo or methyl, we go alphabetical. Okay, so we have 2 bromo, 2 methyl, butane. Okay. So if we look, this was actually a multiple choice question. If we look at the possible answers, we have A, which is 2-bromo-3-methyl butane, B, 2-bromo-2-methyl-butane, C, 3-bromo-3-methyl-butane, and D, 3-bromo-2-methyl-butane. And so B is our answer that we got. So we circle B and we write our answer B there. Okay, now one thing to note is one other one of these, A, is actually a product of this reaction as well. So they very, very intentionally put A as an answer, because there will be individuals who will not have read the question properly and will do their mechanism and just automatically say, my answer's there, the answer is A, happy days, move on, and it will be wrong. So why is A wrong? So A is looking at that secondary carbocation, so the other intermediate that we looked at. So if I write the other intermediate out again, and we can see how A becomes a possibility. So we have H3C. Oh, that's sloppy. Let's try that again. So that there could be our carbocation, in which case our bromide is going to go there, and we're forming this product. Oh, what am I doing? Sorry. You're probably screaming at the screen telling me to go faster. Okay, there we go. Got it. Success. All right, so we still have our longest chain being 4 carbons, so we still have butane. But now, if we look at where the groups are coming off of that main chain, it's there and there. Okay, now your halogen is going to take priority over that methyl group. So when we're naming it, we want the halogen to be on the lowest carbon or lowest number carbon. So this, in this case, we're going to go 1, 2, 3, 4, so that the bromine is on the second carbon rather than 1, 2, 3, 4, rather than the third carbon. So 1, 2, 3, 4. So that is 2 bromo. And now we have 1, 2, 3 methyl butane. Okay, so if we look back at the question, the 2-bromo-3-methyl-butane is A. Okay, so this does form, we can see in the mechanism that you do get that product, but this product is the minor product. Okay, so do watch out for that. They will put answers that are correct, but they're just not right for the question that's being asked. Okay, so because they asked for the major product, A is wrong. Okay, right. So that is just a quick show of how you can use this mind map, and then also a quick review on mechanisms as well. Okay, so in future videos, I am going to have more challenging molecules. So if we look at a little bit more challenging, this is not a synthesis question, okay, but that molecule by far is more challenging, particularly because you may never have seen it before, and they will throw molecules that you've never seen before, and your immediate response is going to be like, oh, I never learned about this, I can't do it, but you need to slow your brain down, and you need to to just look at it and break it apart, because you have seen these before. Okay, you've seen a ketone before. We have a ketone, we have an alkene, we have an alcohol, we have a carboxylic acid. So you've seen those before. And as soon as you identify those functional groups and you look at your mind map, you all of a sudden know how they react. Okay, and you can predict the different reactions that a molecule like this can undergo. Okay, so that's to come in future videos. Hopefully quite soon I'll get them up if I have not already. And then I hope you found this video useful, if at least just introducing a different way of tackling organic chemistry. So if you have any questions, you notice that I made a mistake, because we all know that could very well have happened, leave a comment. I'll answer, make corrections as quickly as I can. Just remember the slight time difference. So what's quick for me might be slow for you. So just be a little bit patient. I will get back to you. And then if you have any other thoughts that you want to share, you can leave those as well. All right, good luck with your studying, and remember, you are awesome and you totally have this.